No signal? No problem. With Premium, you can open up a new world of listening possibilities. Download and play what you want to hear wherever you go offline. And with ad-free music listening, it's easier to stay in the zone without audio interruptions. Get 1 month of Premium free. Hit the banner to learn more. You're constantly evolving, just like your one-of-a-kind playlists. With Spotify Premium, it's easier than ever to play what you love and expand your library offline. Just download your favorite tunes and take off on your next adventure. Get 1 month of Spotify Premium free. Tap the banner to learn more.
What is the length of arc ABC? So arc ABC is this arc right over here. And the reason why they have to give us 3 points, because if they just said arc AC, it would still be ambiguous because there's two arc ACs. It could be this arc right over here, or it could be this arc over here. And so when they tell us B, we know that we're going from A to C through B. So that's why this kind of, by giving us a third. Let's first think about the circumference, 3 inches. So the circumference, or 2 times 3 is 6 times pi. So it's going to, if you look at the choice, pi, 6 pi inches. Now, and actually, if you look at if you look at the choices, over here, the entire circumference of the circle is 6 pi inches. And remember, pi is 3.14159, so this is going to be something in the, it's going to be a little bit over 18 or 19 inches. And so you could immediately, if the entire circumference is a little over 18 or 19 inches, this is only a fraction of that entire circumference. So actually, if you even were looking at the choices, you say, well, okay, these are way too large. But actually, let's see if we can get to the exact right answer. So the entire circumference is 6 pi inches, but this arc length isn't the entire circumference. It only goes 135 degrees out of 360 degrees. So we could say, so it is 135 3/60th of the entire circumference. Remember, if we were to go all the way around, that's 360 degrees, while this angle right over here is 135 degrees, the angle that is subtended by this arc. So this arc length is going to be 135 3/60ths of the entire circumference. So times 6 pi inches. So let's see if we can simplify this a little bit. So let's see, 300, we can divide the numerator and the denominator by 6. 6 divided by 6 is 1. 360 divided by 6 is 60. And let's see, if we divide 135 by 5, that is going to be 27. Yeah, 100 divided by 5 is 20. And then 35 divided by 5 is 7. So this is going to be 27. And then this would be 12 if we divide 60 by 5. And let's see, we could then divide we can divide the numerator and denominator by 3. 27 divided by 3 is 9. And 12 divided by 3 is 4. So we're left with 9/4 times pi inches. So 9/4 times pi inches, or we can multiply the numerator times the pi. We would say 9 pi over 4 inches. And when you look at the choices, that is this one. That is this one right over there, inches. And when you look at the inches, okay, then 6 divided by 6 is circle is going to be 6 times pi. Choices, if you 6 pi inches. Now, and actually, if you look at the choices over here, the entire circumference of the circle is 6 pi inches. And remember, pi is 3.14159, so this is going to be some.
Need something to keep the peace? The Spotify Premium Family Plan gives everyone under the same roof equal listening freedom with separate accounts. Each person can enjoy the premium perks of offline and ad-free music listening from anywhere. Plus, explore music recommendations tailored to your tastes. Tap the banner to learn more.
circle has a circumference of 10 pi feet. An arc x in the circle has a central angle of 260 degrees. What is the length of x? Let's just visualize what's going on here. So we have a circle. I can't draw a circle that well, but we get the point. So that's our circle. This is the center of our circle. It has a circumference of 10 pi feet. So if you go all the way around the circle, it has a circumference of 10 pi feet. Now you have an arc x. You have an arc x in the circle that has a central angle of 260 degrees. So let's think about it. So 260 degrees. So if you go straight up, so if you go this far, it'd be 90 degrees, 180 degrees. If you were to go all the way here, you get to 270. So it's going to be right around, at least approximately right around there. So that would be a central angle of 260 degrees. And this is the arc. This is arc. Let me do something color. Let me do it in purple. So this is arc x right over here, and we want to figure out its length. Well, think about it this way. Its central angle is 260 degrees. What's the central angle of the circumference? Well, the circumference is going all the way around. So if you're going all the way around, that is 360 degrees. 360 degrees. So the fraction that arc x is, the length of x is, of the entire circumference, that's going to be the same fraction that it's, so degrees. So if you go straight up, that would this part right around. This is 20 degrees. Fraction, maybe this way. 260, 15, let's see. Just so you see it, 220, 224 is one of the choices right over here.
Music is personal. Have the power to set the tone from start to stop with Spotify Premium. Listen to all your favorite playlists and albums in any order, and download any track to play offline, all with no ad breaks. Just uninterrupted music listening. Tap the banner to learn more.
So what we have depicted here is a unit circle centered at point A, and the point B lies on the circle, and then we drop the perpendicular from point B to point D. Point D lies on the positive x-axis, and they form this triangle ABD. And they tell us it's an angle BAD, angle bad. It has a measure of pi over 4 radians. What I want to do in this video is use our knowledge of trigonometry and use our knowledge of triangles in order to figure out several things. So the first thing we want to figure out is what's the measure of angle, what's the radian measure? What's the radian measure of angle ABD, Actually, let's just do that first, and then I'll talk about the other things that you need to think about. So I assume you paused the video and tried to do this on your own. So let's think about what ABD would be. We know two of the angles of this triangle. So if you know two of the angles of this triangle, you should be able to figure out the third. Now, what might be a little bit unfamiliar, we're used to saying that the sum of the interior angles of a triangle add up to 180 degrees. But now we're thinking in terms of radians. So we could say that the sum of the angles of a triangle add up to, instead of saying 180 degrees, 180 degrees is the same thing as pi radians. So this angle plus that angle plus that angle are going to add up to pi. So let's just say that this right over here, let's just say measure of the sum of them, the interior angles over 4, I just subtracted these, is going to give us 2. We know this is a unit circle. So we know the length of segment AB, that this, which is the radius of the circle, is the radius of the circle. We can group to that side. What else do we know about this triangle? Can we figure out the lengths of segment AD and the length of segment DB? Well, sure, because we have two base angles that have the same measure. That means that the corresponding sides are also going to have the same measure. That means that this circle pi, this is minus 2 pi over 4, and this, of course, is minus pi over 4. So 4 minus 2 minus 1 is going to get us to 1. So this is going to give us 2 pi over 4. So the measure of angle ABD is actually the same as the measure of angle BAD. It is pi over 4. So that angle right over there is pi over 4. Now, what does that help us with? So if we know that this is pi over 4, and that is pi over 4 radians. And once again, we know this is a unit circle, so we know the length of segment AB, that this, which is the radius of the circle, is like 1. What else do we know about this triangle? Can we figure out the lengths of segment AD and the length of segment DB? Well, sure, because we have two base angles about this triangle circle, so we know the length of segment AB, that this, which is the radius of the circle, is like 1. What else do we know about this triangle? Can we figure out the lengths of segment AD and the length of segment DB? Well, sure, because we have two base angles that have the same measure. That means that the corresponding sides are also going to have the same measure. That means that this side is going to be congruent to that side. I can reorient it in a way that it might make it a little easier to realize. If we were to flip it over, not completely flip it over, but if we were to make it look like this, so the triangle, we can make it look like a little bit more like this. Actually, I want to make it look like a right angle though. So my triangle, let me make it look like, there you go. So if this is D, this is B, this is A, this is our right angle. Now this is pi over 4 radians, and this is also pi over 4 radians. When your two base angles are the same, you know you're dealing with an isosceles triangle. An isosceles, but because they're not all the same, you know it's not equilateral. If all the angles are the same, it's equilateral. This is an isosceles non-equilateral triangle. So if your base angles are the same, then you also know that the corresponding sides are the same. These two sides are the same. This is an isosceles triangle. And so how does that help us figure out the lengths of the sides? Well, if you say that this side has length x, that means that this side has length x. If this side has length x, then this side has length x. And now we can use the Pythagorean theorem. We could say that this x squared plus this x squared is equal to the hypotenuse squared, is equal to 1 squared. Or we could write that 2x squared is equal to 1, or that x squared is equal to 1 over 2, or just taking the principal root of both sides, we get x is equal to 1 over the square root of 2. And a lot of folks don't like having a radical in the denominator, don't like having a rational number in the denominator. So we could rationalize the denominator by multiplying by the square root of 2 over the square root of 2, which would be, the numerator will have the square root of 2, and in the denominator, we're just going to have square root of 2 times square root of 2 is just 2. So we've already been able to figure out several interesting things. We were able to figure out a measure of angle ABD in radians, we were able to figure out the lengths of segment AD and the length of segment DD. Now what I want to do is figure out what are the sine, cosine, and tangent of pi over 4 radians, given all of the work that we've done. So let's first think about what is the sine. Let me do this in a color, do an orange. Given all the work we've done, what is the sine of pi over 4 radians? And I encourage you once again, pause the video, think about the unit circle definition of trig functions, and think about what this is. Well, the unit circle definition of trig functions, and this angle is pi over 4 radians, is forming an angle with a positive x-axis, and where its terminal ray what I have attempted to draw here is a unit circle. And the fact that I'm calling it a unit circle means it has a radius of 1. So this length from the center, and I centered it at the origin, this length from the center to any point on the circle is of length 1. So what would this coordinate be right over there, right where it intersects along the x-axis? Well, it would be x would be 1, y would be 0. What would this coordinate be up here? Well, we've gone 1 above the origin, and we haven't moved to the left or the right, so our x value is 0, our y value is 1. What about back here? Well, here our x value is -1. We've moved 1 to the left, and we haven't moved up or down, so our y value is 0. And what about down here? Well, we've gone a unit down, or 1 below the origin, but we haven't moved in the xy direction. So our x value is saying I'm going to find a convention for positive angles. I'm going to say a positive angle, well, the initial side of an angle, we're always going to do along the positive x-axis. So this is you can kind of view it as the starting side of the angle, the initial side of an angle. And then to draw an angle up for positive angle, we've gone a unit down, or 1 way, I'm going to draw an angle. And then the way I'm going to draw this angle, I'm going to define a convention for positive angles. I'm going to say a positive angle, well, the initial side of an angle, we're always going to do along the positive x-axis. So this is you can kind of view it as the starting side of the angle, the initial side of an angle. And then to draw an angle, a positive angle, the terminal side, we're going to move in a counterclockwise direction. So positive angle means we're going counterclockwise. Counterclockwise. This is just the convention I'm going to use, and it's also the convention that is typically used. And so you can imagine a negative angle would move in a clockwise direction. So let me draw a positive angle. So a positive angle might look something like this. This is the initial side, and then from that I go in a counterclockwise direction until I measure out the angle, and this is the terminal side. This is a positive angle theta. And what I want to do is think about this point of intersection between the terminal side of this angle and my unit circle. And let's just say it has the coordinates a, comma, b. The x value where it intersects is a, the y value where it intersects is b. And the whole point of what I'm doing here is I'm going to see how this unit circle might be able to help us extend our traditional definitions of trig functions. And so what I want to do is I want to make this theta part of a right triangle. So to make it part of a right triangle, let me drop an altitude right over here, and let me make it clear that this is a 90-degree angle. So this theta is part of this right triangle. So let's see what we can figure out about the sides of this right triangle. So the first question I have to ask you is, what is the length of the hypotenuse? What is the length of the hypotenuse of this right triangle that I've just constructed? Well, this hypotenuse is just a radius of a unit circle. The unit circle has a radius of 1, so the hypotenuse has length 1. Now, what is the length of this blue side right over here? This blue side, you could view this as the opposite side to the angle. Well, this height is the exact same thing as the y coordinate of this point of intersection. So this height right over here is going to be equal to b. The y coordinate right over here is b. This height is equal to b. Now, exact same logic. What is the length of this base going to be? The base just of the right triangle. Well, this is going to be the x coordinate of this point of intersection. If you were to drop this down, this is the point x is equal to a, or this whole length between the origin and that is of length a. Now that we have set that up, what is the cosine? And what is the cosine? Use the same green. What is the cosine of my angle going to be in terms of a's and b's and any other numbers that might show up? Well, to think about that, we just need our SOHCAHTOA definition. That's the only one we have now. We are actually in the process of extending it. SOHCAHTOA definition of trig functions. And the ka part is what helps us with cosine. It tells us that the cosine of an angle is equal to the length of the adjacent side over the hypotenuse. So what's this going to be? The length of the adjacent side, for this angle, the adjacent side has length a, so it's going to be equal to a over, what's the length of the hypotenuse? That's just 1. So the cosine of theta is just equal to a. Let me write this down again. So the cosine of theta is just equal to a. It's equal to the x coordinate of where this terminal side of the angle intersected the unit circle. Now let's think about the sine of theta. Sine of theta, and I'm going to do it in, let me see, I'll do it in orange. So what's the sine of theta going to be? B. Well, we just have to look at the SO part of our SOHCAHTOA definition. It tells us that sine is opposite over hypotenuse. Well, the opposite side here has length b, and with the hypotenuse has length 1. So our sine of theta is equal to b. So an interesting thing, this coordinate, this point where our terminal side of our angle intersected the unit circle, that point AB, we could also view this as A is the same thing as cosine of theta, A is the same thing as cosine of theta, and B is the same thing, B is the same thing as sine of theta. Well, that's interesting. That was just, we use our SOHCAHTOA definition. Now, can we in some way use this to extend SOHCAHTOA? Because SOHCAHTOA has a problem. It works out fine if our angle is greater than 0 degrees, if we're dealing with degrees, and if it's less than 90 degrees. We can always make it part of a right triangle. But SOHCAHTOA starts to break down as our angle is either 0 or maybe even becomes negative, or as our angle is 90 degrees or more. You can't have a right triangle with two 90-degree angles in it. It starts to break down. Let me just make this clear. So sure, so this is a right triangle, so the angle is pretty large. I can make the angle even larger and still have a right triangle even larger, but I can never get quite to 90 degrees. At 90 degrees, it's not clear that I have a right triangle anymore. It all seems to break down. And especially the case what happens when I go beyond 90 degrees. So let's see if we can use what we set up here. Let's set up a new definition of our trig functions, which is really an extension of SOHCAHTOA, and it's consistent with SOHCAHTOA. Instead of defining cosine as, if I have a right triangle and saying, okay, it's adjacent over the hypotenuse, sine is the opposite over the hypotenuse, tangent is opposite over adjacent, why don't I just say, for any angle, I can draw it in the unit circle using this convention that I just set up, and let's just say that the cosine of our angle is equal to the x-coordinate where we intersect, is equal to the x-coordinate where the terminal side of our angle intersects the unit circle, where angle, I'll write the terminal side of angle intersects the unit circle. And why don't we define sine of theta to be equal to the y-coordinate where the terminal side of the angle intersects the unit circle. So essentially, for any angle, this point is going to define cosine of theta and sine of theta. And so what would be the reasonable definition for tangent of theta?
No signal? No problem. With Premium, you can open up a
tangent of theta,
new
even with
world of
SOHCAHTOA, could be
listening
defined as sine of theta
possibilities.
over
Download
cosine of
and
theta,
play what
which
you
in this
want to
case is
hear
just going to
wherever
be
you
the
go
y-coordinate where we
offline.
intersect the unit circle
And with
over
ad-free music
the
listening,
x-coordinate.
it's easier
In the next
to
few
stay in the
videos, I'll show some
zone
examples where we use a
without
unit circle
audio
definition
interruptions.
to start
Get 1
evaluating
month of
some
Premium
trig
free.
ratios.
Hit the banner to learn more.
On the right-hand side, we have a bunch of expressions that are just ratios of different information given in these two diagrams. And then over here on the left, we have the sine taken of angle MKJ, cosine of angle MKJ, and tangent of angle MKJ. And angle MKJ is this angle right over here, same thing as theta. So these two angles have the same measure. We see that right over there. And what we want to do is figure out which of these expressions are equivalent to which of these expressions right over here. And so I encourage you to pause the video and try to work this through on your own. So assuming you've had a go at it, so let's try to work this out. When you look at this diagram, it looks like the intention here on the left is this evokes the unit circle definition of trig functions, because this is a unit circle right over here, and this evokes kind of the SOHCAHTOA definition, because we're just kind of in a plain vanilla right triangle. And so just to remind ourselves, let's just remind ourselves of SOHCAHTOA, because I have a feeling it might be useful. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. adjacent over hypotenuse, and tangent is opposite over adjacent. So we can refer to this, and we can also remind ourselves of the unit circle definition of trig functions, that the cosine of an angle is the x-coordinate, and that the sine of where this ray intersects the unit circle, and the sine of this angle is going to be the y-coordinate. And what we'll see through this video is that they're actually, the unit circle definition is just an extension of SOHCAHTOA. So let's look first at x over 1. So we have x is the x-coordinate, that's also the length of this side right over here. Relative to this angle, theta, that is the adjacent side. So x is equal to the adjacent side. What is 1? Well, this is a unit circle. 1 is the length of the radius, which for this right triangle is also the hypotenuse. So if we apply the SOHCAHTOA definition, x over 1 is adjacent over hypotenuse. Adjacent over hypotenuse, adjacent over hypotenuse, that's cosine. So that's going to be, this is equal to cosine of theta. But theta is the same thing as angle MKJ. They have the same measure. So cosine of angle MKJ is equal to cosine of theta, which is equal to x over 1. Now let's move over to y over 1. Well, y is going to be the length of in the figure at left, I pasted it up here, point O is the center of a circle of radius 1.5. You see that right there. The missing sector of the circle has central angle AOB equal to 2 pi over 3 radians. That's this right over here, and that's the central angle for the missing sector right over there. What is the length of arc ACB? Now ACB is this arc. It's kind of the rest of the circle, the part that's not missing. So this is ACB right over here. Well, the way that I would tackle this, I would think, well, what's the circumference of the entire circle? And then what fraction of the entire circle is this arc length? So let's first think about the circumference of the entire circle. Circumference is equal to 2 pi times r. In this case, our radius is 1.5. So it's going to be 2 pi times 1.5. Now 2 times 1.5 is 3. And so this is going to be equal to 3 pi. So the circumference of the entire circle is 3 pi. Now there's a couple of ways you could do it. You could figure out, well, what is the length of this arc right over here, and then subtract that from the circumference, and then you'd be left with the magenta part. Or we could figure out the central angle of the magenta part. We could figure out this angle and think about, well, what fraction is that going to be if we were to go all the way around? And if we're thinking in radians, going all the way around is 2 pi radians. So what fraction is this angle of 2 pi? And then that's going to be the same fraction that this arc length is of the entire circumference. Well, what's this angle going to be? Well, it's going to be, if we went all the way around the circle, that'd be 2 pi radians. If we want to figure out this magenta central angle, it's going to be 2 pi minus this 2 pi over 3. So this is going to be 2 pi. Magenta color. So the central angle for this piece of the circle, or that's kind of the central angle for ACB, is going to be 2 pi minus 2 pi over 3. I'm going all the way around, but then I'm subtracting out this part right over here. Now what's 2 pi minus 2 pi over 3? Let's see, I can find a common denominator. Instead of writing it as 2 pi, I can write that as 6 pi over 3. So let me do that. It's going to be 6 pi over 3 minus 2 pi over 3. Well, that's going to be 4 pi over 3. 4 pi over 3. So once again, this angle right over here is 4 pi over 3. 4, and then write that as 6 pi over 3. So let me do that. It's going to be In the xy plane above, O is the center of the circle right over here, and the measure of angle AOB is 5 pi over 6 radians. If the radius of the circle is 6, what is the y coordinate of point A? Pause this video and see if you can figure this out before we work through this together. All right, now let's work through this. And if all of this seems really unfamiliar, I encourage you to review degrees and radians or circle trigonometry on Khan Academy. But I'll assume you have some familiarity with it. So first of all, they're telling us that the measure of angle AOB is 5 pi over 6 radians. So AOB, we're talking about this angle right over. Over here is 5 pi over 6 radians. We know that I am radians, that pi 2, so you might write one angle is 90 angles. And that by itself lets us know what's going on, because this is 1/2 the radius. That's what we need to figure out. The radius is 6, so 1/2 times 6 is equal to 3. And we're done. That is the y coordinate over here. It is 3. 6, so 1/2 times 6. I'll have to add up to 180, and this is a typical triangle you'll see a lot in your geometric career, so it's good to know about 30, 60, 90 triangles. And we also know that in 30, 60, 90 triangles, the side that is opposite the 30 degrees is 1/2 the radius. And we also know they'll have to add up to 180, and this is a typical triangle you'll see a lot in your geometric career, so it's good to know about 30, 60, 90 triangles. And we also know that in 30, 60, 90 triangles, the side that is opposite the 30 degrees is 1/2 the radius. And that by itself lets us know what's going on, because this is 1/2 the radius. That's what we need to figure out. The radius is 6, so 1/2 times 6 is equal to 3. And we're done. That is the y coordinate over here. It is 3. In the xy plane above,
Do you want to make the most of your playlists? With Spotify Premium, you can listen to all the songs that fuel your fire without hearing ads. Play it loud and play it proud, without music interruptions. Get 1 month of Spotify Premium free. Tap the banner to learn more.
is going to be equal to pi over 6 radians. Now, this still might not be familiar to you. What is pi over 6 radians? Well, you could think about converting that to degrees. We know that pi radians is equal to 180 degrees, because pi radians is halfway around the circle. So you divide that by 6.
Testing our knowledge.
यस्तो फोटो के सेयर गरेको यार साबुन लाउनु अब कस्तो धमिलो
मेरो फोन नै कस्तो अपडेट आएपछि झन्झन क्यामेरा क्वालिटी नराम्रो मन भयो अमिलो
मेरो स्यामसङ A24 त असम छ यार नमिलो न धमिलो
50 मेगापिक्सल भएको नो शेक क्यामेरा प्रिमियम डिजाइन उज्यालो सुपर एमोलेड स्क्रिनको साथै दिनभरि चल्ने 5000 mAh को पावरफुल ब्याट्री भएको Samsung A24 awesome छ यार.
The equation of a circle C is x plus 3 squared plus y minus 4 squared is equal to 49. What are its center
However
HK
you like
and its
to
radius
listen,
R? So let's just
there's
remind
a
ourselves what a
premium
circle
plan
is.
made for
You have
you.
some point, let's call that
Add up to
HK.
6 accounts
The
with
circle is a set of all
family
points
plan
that
to share
are
the love
equidistant
with
from that
people under
point.
the same
So
roof.
let's take the set of all
Join
points
the
that are, say,
duo plan
R away
or
from
go
HK.
solo with
So
the
let's say that this
individual
distance right over
plan
here,
and get a
this distance right
discount
over
as a
here is
student
R.
while enjoying
And so we want all the set of
offline
points that are
and
exactly
ad-free
R away.
music
So all the
listening.
points X comma
Get
Y that are
one
exactly
free
R
month
away.
of
And so you can imagine you could rotate
Tap
around and all of these
banner
points are
to
going to be
learn
exactly R away. And I'm going to try my best to draw at least a somewhat perfect looking circle. I won't be able to do a perfect job of it, but you get a sense. All of these are they're exactly R away, at least if I were to draw it properly. They are R away. So how do we find an equation in terms of R and HK and X and Y that describes all these points? Well, we know how to find the distance between 2 points on the coordinate plane. In fact, it comes straight out of the Pythagorean theorem. If we were to draw a vertical line right over here that essentially is the change in the vertical axis between these 2 points, up here we're at Y, here we're K, so this distance is going to be Y minus K. We can do the exact same thing on the horizontal axis. This X coordinate is X, while this X coordinate is H. So this is going to be X. This is going to be X minus H is this distance. And this is a right triangle because by definition, we're saying, hey, this is a vertical, we're measuring vertical distance here, we're measuring horizontal distance here, so these two things are perpendicular. And so from the Pythagorean theorem, we know that this squared plus this squared must be equal to our distance squared.